And there we are. Greetings, fellow nerds. Welcome to another episode of Between Two Nerds. I'm your host, Jeff Doyle, and my friend and co-host, Jeff Tansura, is off this week. He's been traipsing all over Europe at Vienna for IETF and in Paris for MPLS World, and I don't know where he is now, but he's still terrorizing Europe. So I'm running everything on my own, but I am very happy to have three good friends today, and they're all old friends of mine, and they are all IPv6 guys. And for a long time, I was kind of known as an IPv6 guy too. I've kind of gotten out of that area, but these guys are still in it up to their eyeballs. And so I want to introduce Ed Horley, Tom Coffeen, and Cody Christman. And I'd like for each of you guys to just maybe briefly introduce yourselves and what you do, and what your relation is to IPv6. How's that?
Sure. You want me to? You guys want me to go first? I'll go.
Go for it, Ed.
So I'm Ed Horley. I wrote a book on V6, although I don't think anyone reads it annhưng because it's been a while. Yeah, there it is.
There it is.
IPv6 for Windows administrators.
There we go.
People still using Windows, but yeah, no. Let's see here. Tom and I and Cody all work together at Hexabuild doing V6 related projects, mainly for Fortune 1000 and federal and sort of those enterprise customer base, and just have a great time working on V6 related projects. And Jeff, I know it's been a long time since we got a chance to work together, but I think like McTissa, like the Marine Corps or something way back when, doing some V6 work way back then. But yeah,
that's Camp Pendleton.
Yep, so it's a long time ago. But anyway, yeah, it's just good fun working on V6 related projects and stuff of that nature, and been doing that for 20 plus years now. So, yeah. Tom, how about you?
Well, Ed, you talked me into writing a book as well. You weren't miserable enough in your own experience writing one. So, and it's funny because that was the same. That was right around the same time as the Texas V6 task force meeting where Jeff, you were talking about IPv6 and doing some whiteboarding about how much IPv6 address space there was to go around, and a sort of light bulb went off over my head. I was just like, wow, this is something that I definitely had thought I was thinking about it as expansively as I needed to, and then realizing that when you get into the address planning piece, that's the first place you just go right into the ditch. Yeah. So, and I certainly did with my first V6 deployment back in the day, back in the 2000s. So yeah,
I've got your book on my shelf. I know I've got your book, and sorry, my apologies. I don't have it.
No worries.
So that I could wave in front of the camera.
Yeah. No worries. Yeah, IPv6 address planning. So that's what I like to geek out on, and the vast expanse of V6 that we have at our disposal to finally solve operational problems that we just couldn't solve with V4. I'm excited about that, and we get to do some of that at Hexabuild. So, and I'm glad to be here today, Jeff. Thanks for the invite.
I'm glad you're here. Cody.
Hey, yeah, thanks for the invite, Jeff. Really appreciate it. Cody Christman. I'm also with Hexabuild. I'm a principal consultant there. And I guess Jeff and I go back, the first time I heard of IPv6 was in the kind of late 90s. We were working on Solaris, and a guy that was either working for me at the time or with me, Chuck Sellers, probably introduced us. Yep. It was kind of back when the Rocky Mountain IPv6 task force kind of got kicked off. So it was either late 90s or early 2000s. And, Jeff was instrumental in that. He was a founding member along with Chuck Sellers and Scott Hogue, who isn't with us today, but is also a founder of Hexabuild. A lot of you that are in the IPv6 world, you definitely know Scott. So, at the time I was working for Nippon Telegraph and Telephone, a tier 1 ISP. And so I've known Jeff for a long time and been involved with the Rocky Mountain IPv6 task force. I have not written a book,
but he's edited a lot.
I have nothing to wave at the camera.
Yeah. So, I used to go to, back in the 2000s and in that era, went to all these IPv6 conferences. And at one of those events out in like the DC area and Virginia somewhere, I met Sylvia Hagen. And, she's a friend of ours, I think, lives in Switzerland. She's Swiss. Lives in Switzerland. And she'd written that book, O'Reilly IPv6 Essentials.
Yeah.
And one day I got an email from her after I'd met her, and she said, "Hey, would you be willing to write a little case study chapter for the second edition of my book?" So I did write a little blurb for her that is in there, and just another great book. So, but anyway, thanks for having me on. I really appreciate it, Jeff.
Well, you're the only one that I know. We all own IPv6 shirts, and you're the only one that actually no longer optional. I didn't see that part. That's great. And maybe that is a great place to kick off on this. Is IPv6 no longer optional? Is that true?
I guess it depends on who you ask. I guess that's a reasonable answer, right? I think for the service providers, which is, I think, Jeff, where you principally spent a lot of time helping all the mobile and big service providers really adopt V6, I would say they're pretty much done. Like all the tier 1 providers, like you did a great job helping them get across the finish line, right? So they pretty much are done and ready to go. And so there's a whole community that is like totally V6 ready, and that space is sort of done and ready to go. So for them, it's definitely not optional because they're running production workload on it every single day, and that's what they do. I'd say that the folks that are fitting in the next category are probably like home consumers who don't know any better because those service providers are pushing them V6 and they just don't know that they're using it. And that's perfectly fine. That's how it was supposed to work. It's going by plan. We're literally taking over the world and it's working. But I would say they fit into the, they just don't know that it's optional, or they don't know that it's not optional. They just know that they've got internet at home and it works. And I think that's fine for that space. So I think the ones that are left over are like, federal and government agencies where regardless of where they are in the world, and then all those enterprise and sort of commercial businesses. Like those are the ones that are left over. They're like, what do we do here? We don't really know what to do. The biggest fortunes are definitely figuring out it's not optional for them. They are structurally trying to solve really big problems, and they're realizing that they get a whole set of benefits and capabilities out of V6 in addition to just the proliferation of address space and the fact that many of the organizations they're working with now are running and operating V6, and that's just their reality. That's the world they're in. And so Tom has gotten to work on a ton of just like pretty amazing address plan requirements for some of the biggest organizations in the world. And so it becomes a very different story because we're starting to talk much more about shifting left like on the nibble side of like the, back when we were probably all gabbing on a regular basis in the 2010s and saying, what's it going to look like? Oh, 32 is enough. Yeah, 32 isn't enough. Like, we're getting into much bigger allocations for companies because we're thinking very differently about where V6 needs to be applied and thought about. And that's probably a whole different discussion that Tom can get into, talking about thinking differently about the address space itself and what we can operationally do with it, which I think is sort of unique. And that's where I think it does not become optional because it's impossible to do in V4. This is one of those unique use cases where it's not possible to do something in V4. It is possible to do it in V6, but there's a very big jump. We call it the V4 thinking jump, right? Of learning how to stop thinking about V4 and start thinking about what's possible, and then using V6 to solve those issues. So that's sort of the space we're in.
Something you said early on in that was talking about transition and people not actually knowing that they're on V6. And when I was traipsing around talking about V6 and talking about transition technologies, which, there was a set of like a dozen quote unquote transition technologies that were being proposed, and a lot of them were just absurdly complex, involved the user and all kinds of things like that. And one of the blurbs I used to say back then was, if the user is aware that they're transitioning from IPv4 to IPv6, then the transition has failed.
Yes,
because it should be transparent. And and another example is talking on your cell phone. Depending on who your provider is, you're probably talking over an IPv6 connection, almost for sure. But Tom. One of the things I know that is maybe one of the most challenging pieces and feel free to disagree with me, but one of the most challenging pieces of transitioning from IPv4 to IP or adopting IPv6 is the addressing plan, because all of us, at least those of us who have gray hair, have had it beat into us that we need to be conservative with our IPv4 addressing plans. And I know I made a lot of presentations saying, throw away everything you've been taught about IPv4 address plans, because IPv6 is different. And do you still agree with that?
Yeah, I really do. That's a softball, Jeff, right over the plate. And you mentioned related to there's kind of a feather in the cap that you get pretty early on. At least I felt it was, and maybe that's just significant to how mathematically challenged I am. But there's that sort of moment of magic when you get your mind around subnetting, and you get your mind around what subnet masks are, and how to manipulate subnets and masks and do VLSM, and that's a tremendously powerful tool in your belt when you don't have enough IP addresses and subnets to go around. And so you come to rely on that very heavily, and that becomes the primary mental model that you use, and so then all of a sudden you go to the address registry, and they hand you this block of addresses, and you start trying to do a little bit of back of the envelope math to figure out, where am I with this? What am I going to do with this address space? And right away you go off the rails, because you're dealing with a scale of addressing and a scale of more generally a resource that you're just not used to having abundance of to that degree, and it becomes very difficult to sort of swap out that mental model of subnetting and VLSM. And so you just, in your nervousness, at least for me, in my nervousness and my anxiety, it's like, I've got this big block of addresses, and what do I need to do? Well, I know I'll start carving things up, and the faster I can carve things up, the more I'll make progress on this plan. And of course, that is, not the direction to go in. And as Ed pointed out, we're moving into, the service provider and the subscriber networks and the content providers, they've gotten the memo, and V6 is sort of firmly established there. And now we're left with the enterprises and the federal agencies. And there's this sort of paradigm shift that's happening related to how they're building their networks and how they're architecting their networks. That's about, moving, there's the on-premise component, but then, moving into the cloud and dealing with IoT and the way in which you're going to have to start thinking about how to manage all of that operationally, the center of gravity shifting away from just the on-premise network. And so sure, if you got a /32 from Aaron back in the day, and that was for your on-premise network, and let's say that was 2012, well, you weren't really thinking about the possibility of multi-cloud network architecture in 2012, or very few people were. So, what does an allocation have to look like now in an environment where, I've got my on-premise resources, and the catch here is that, sure, I could start carving things up, but at any point I can fall back to, subnetting by bits, and that's like an escape hatch that's going to give me what I need to do. It's going to give me the address resources that I need for whatever the application is. But if I've gone through all the trouble to set up my on-premise network in this operationally sane way, where I'm using, nibbles everywhere and everything is very clearly identified, now as I expand into the cloud, and this is the comment Ed made about everything sort of shifting to the left, consuming more bits to the left, consuming more of the prefix space, and not being so concerned about, how much site space that I have for each of those applications. But the implication is that we're going to be seeing operational models that are trying to accommodate both on-premise and multi-cloud network, where the allocations are similarly sized. And it doesn't have to be a one step. The more that you can bake that in at the beginning of the plan, the more freedom and latitude you have for your architecture and your designs going forward. That you shouldn't take that away from yourself at the outset, by doing a bunch of very specific carving up of networks. And so,
something that I advocated quite a bit way back when, and then again, that's been 10 or more years ago, that I don't think was ever completely adopted, but I really liked the idea of a standard IPv6 allocation unit of a /48 prefix, and and give that to everybody. Give it to a home, and as soon as you say that, a /48 into a home, oh my gosh, that's so wasteful. All these the thousands and thousands of subnets that I'll never use, and with each subnet having thousands and of addresses within it, and the response is, yeah, but look how big the IPv6 address space is, and wastefulness no longer matters. And for a company, maybe let the company, without having to justify it, say, yeah, I want a /48 per building. Maybe I want it a /48 per floor, per campus, whatever they feel comfortable with their allocations, but make that a standard unit, so if I need multiple /48s, I can get them. So my question is that naive, or is it, is that still something that's viable to advocate?
Well, I think it's still a viable set of discussions. I think things have moved, or the land has shifted a little bit in terms of what defines a site, which I think, Jeff, is what your original point was defining what that site is and what that functional component is, and at what level do you define a site. And so, getting back to maybe theme of your show a lot is data center. Is a 48 enough for a data center?
Yeah.
Do you need more than that? Are you running large-scale Kubernetes clusters that you need to have, that you want to have them be able to do service discovery without doing weird NAT translation through v4 and have weird sideload, Istio and Envoy issues, trying to get namespaces to resolve? It's like, okay, well, we can just assign v6. Do we want to assign a 64 to every single host, so that way they can run as much address space as they want behind it without having to interject a lot of neighbor discovery entries, right? We can just no, we just route you the 64 and we're done. Or do we route a 48 and say you're done because of it's going to auto provision services? So maybe you have, scalable data center solutions that are built by an orchestrator. Well, the orchestrator should probably just be assigned to 48 so that you don't have to think about it. Just injects whatever routes you want to put in there for whatever upstream top of rack switching, and just let it do the thing that it needs to do. So there's a lot of options. So the site definition is starting to be, I think, a little bit more granular in terms of where you place it. It might be different within a data center than different than a campus deployment, different than a cloud services model. Because a 48, let's say today, this 48 is /48 is the smallest we can inject into the default free zone, right?
Right.
Well, is that really what you want advertised out of your public cloud provider? They probably don't want to advertise a 48. They probably want to advertise a 44, or they maybe even a 36, right? They probably want something that's more encompassing of all the address space that you might occupy within their domain. And so there's a different trade-off, a different set of tensions about what defines your site and your control of that particular address space. And you probably don't want to make that minimum space for like Anycast purposes or things like that. So there's a different set of discussions, especially at the bigger enterprise level, when you've got like a global footprint. It may look very different in Europe than you look in the US. And so how do you solve that disconnect? And we didn't even touch on the problem of like, should you be getting your address space from Aaron if you're US based, or but you have European operations, should you go to RIPE and go to ask them for address space, or should you do both? Right? Yeah. Or like, there's a whole different set of strategies there and things that work out. So it really depends. And then it's what transition technologies you're also leveraging in the service block architecture to sort of solve that problem. Like Cody worked on a bunch of different stuff around like doing like managed services solutions with v6. That's a totally different space than trying to solve the problem around like, how do we deal with like a bunch of offices or SD-WAN, right? And so there's a whole different set of constructs or problems that you can deal with, and you can use your address space in a very different and sort of unique way to sort of solve those problems too, that you could never do in v4. And in fact, you're using that to transition to talk to all these different islands of v4 address space, but you're operating v6 and you don't want any of them to talk to each other. It's pretty interesting use cases.
Yeah. And I have to mention we've got a few attendees on here that we're attracting IPv6 people because a couple of other very prominent IPv6 guys, Mark Blanchet and Eric Vinke. Eric co-authored a book with our mutual friend Scott Hogue. But Mark has. We were talking about allocation strategies, and he said, "Well, there's always RFC 3531, which happens to be authored by Mark Blanchet." And so, Mark, thanks for mentioning that, and very much, if you're looking at IPv6 address design strategies and allocation strategies, that is an RFC to look at.
We're in the RFC game now.
That's right. That's right. Well, I wish Jeff Tansura was here, because he's in the IETF space. He's sort of been everywhere there, and he's Mr. IETF, I guess.
Well, Eric's no slouch in that category either.
That's right. That's right. And
I was going to say, I think one of the things Tom and Ed were talking about is this awful problem that these people that have deployed V6 have, that, boy, we have way too much address space. How are we going to allocate it? Do we use a 56 or a 48? Mm-hmm. Kind of the flip side of that, I mean, we were talking about, who have been the leaders in deployment, and Tom brought up service providers and content providers. And you talked about, if you're talking on your phone, you're probably going over IPv6. The enterprises are lagging. And I think one of the things everyone's been talking about is, like Tom said, these multi-cloud deployments. You have your on-prem networking, you have multi-cloud, you have Kubernetes, containers. And I think even some smaller enterprises that are maybe saying, look, we don't need to take that step. We don't feel the same pressure that, T-Mobile and Sprint have felt, that Facebook feels, as far as the depletion of our IPv4 address space, public and private. But I think if you kind of look at where your company's going, you need to think down the line so that you can kind of plan for the disruption that's ahead of you. For people that think enterprises that think they may have plenty of IPv4 address space, that might not be the case when you start talking to your cloud team, or, we're going into AWS and Google Cloud and Azure. And well, what are your network requirements there? I'll give you a 24. Well, no, we need more than a 24. And now you start to realize that if you look 5 years down the road, you're even getting squeezed with your RFC 1918 address space. So, and it's this sort of project where it's not rocket science per se, but it does take planning and vision. And it's something I think you want to do on your terms. So the sooner you can get thinking about how you're going to make this transition, and where's my network going in the next 5 years, it's really going to save you. It's going to be way less disruptive, I guess. So
yeah. And Andy Whitaker is watching the show too, and he's got a question on here. He says, I'm really curious to see you touch on what you see for address space at the branch office edges. Oh, there it is. With /48 being minimum length advertisement, no NAT, and multi-circuit edges, what IPv6 subnet size do you see? What are the factors there?
Ed's smiling. I know what he's thinking. Especially with NAT, with that's like waving the red flag in front of the bull. Yeah. but the NAT answer is a little bit more complicated now, right, Ed?
Yeah, I think. Look, the size of the address space for branch office edge is partially dependent on where you're located in the world. So it's partially about whether you're taking PI or PA considerations, Jeff. So if you can do BGP and be able to break things out, then you might have a totally different strategy than if you're using provider allocated resources and you have to deal with every single service provider. And then the real question is what prefix do you actually use on your network?
Yeah.
Right. Like, or do you use all of them? Do you use none of them? Like, we have a tendency for the larger organizations, we tell them to still use their PI space, even if they can't advertise it. And just, the preference is to probably do something like MPTV6 or do, God forbid, NAT66, right? And get them outbound in order to be able to use that. I think there is a lack of operational tools for folks that are used to running V4 networks and design architectures to have something that corresponds with it in V6. We got plenty of address space, but we haven't solved the problems around the design and applications that folks want to use, like SD-WAN. You got 4 different circuits coming in from 4 different providers. You want to be able to balance across them. a bunch of the SD-WAN solutions can do the tunnel overlays on top of that and then balance their application architectures on top of that for things like, I want to reach Office 365, push it out this tunnel. But they don't really have that for v6 from a route perspective of like making it highly available and choosing what prefix actually needs to run on the internal side. And I don't know if we have a really clean answer for that. And this is one of the reasons you don't see enterprises adopting as rapidly in some of these spaces, is because it's not solving the specific problems they need. Service providers don't think about this, right? They've got enough address space. They know how to run BGP. They have enough AS knowledge. They know how to run these sort of topologies. But a lot of enterprises, that's not the business they're in, nor is it the business that they're interested in being in. All right, they're interested in solving problems for their business, and I think that's a clear differentiator. And I think there's a whole set of conversations. If you follow the v6 ops list and you're watching what's going on, there's a lot of discussions about where do the enterprises fit and how do we get feedback from enterprise organizations. We're very fortunate we get to work with a lot of them, so we sort of know where some of those gaps are at today, because they come and complain to us about the fact that they're not happy with some of the answers that are coming back in terms of design architecture, and that's fair. I mean, that's a fair thing. You can definitely use a set of tools today out of what's provided in v6, but is the design as elegant as what you're used to in v4? Probably not. It's a different operational model. That's painful for people. Like, I think that's the biggest consideration, is operational model. This is something I don't know. I don't know if I'm going to stand it up. I don't know how to troubleshoot it. I don't know. I don't understand necessarily all the operational nuances of it. It's not what I'm used to. And those are very common phrases. I think the operational models match a little bit better for v4 and v6 and service provider backbones, just in terms of doing BGP and ASNs and route filters and the whole bit. Just makes naturally more sense there. I think it's a little tougher for the enterprises. And then that's just my opinion. I don't know, Tom, Cody, if you guys agree with that, but that's sort of where.
Yeah, it's really true. And we're a little bit, our vision is a little skewed based on working with larger enterprises. And I know there's some angst in the IETF about the smaller enterprises, and numbers get thrown around about how many there are. And so then the question of, if everybody gets a /48 of PI space, do we have a DFZ that's 10 million /48s because of all the smaller and medium-sized enterprises? And to Andy's question, related to the operational model, related to what a smaller enterprise is going to do is not similar to what a larger Fortune company is going to do. And so the idea, like NAT, isn't necessarily as demonic as it is if you're trying to scale a very large network. If you have one site and this, you can sort of kill two birds with one stone by having a PA allocation from the provider, but then having your own PI space internally that you don't have to number in and out of, and then you're using like something like NPDv6 or NAT66 on the edges as suggested. And then that solves the problem of, you don't have a bunch of extra stuff in the DFZ from single individual /48 PIs that are being handed out to smaller enterprises. But this is a problem space that, I don't think there's been a tremendous amount of progress on. We don't have really good visibility into what those, how it's being solved. I don't think it's really being solved. And it's just not really enough v6 deployment in that area. So it remains to be seen how it will be solved. But there's nothing magical about the /48 in terms of that size. It's certainly, yeah.
Well, I think we should be shifting left. I think
and that was your argument earlier, about and especially for larger enterprises per site. We know we have some large enterprises that they don't want to assign just a single /48 to a large data center or a collection of data centers. They may be using a 44 or even a 40 for some of the, and that in terms of their operational model, it looks very much like just another site. And so if we stick to that, everybody gets a /48, including this larger data center, then that's not sufficient for them. So then the question becomes, for operational consistency, if everything's just to the left, then does every site for that enterprise then get a /44 or a /40? The answer to that question shouldn't be, in my opinion, and I think you probably agree, Jeff, it shouldn't be premised on concerns about exhaustion, concerns about address exhaustion.
Absolutely.
Yeah.
But the other side of that, and I'm sort of seeing a hole in my own argument, and you touched on that too. If specifically to Andy's question, where you're talking about branch offices, and I was saying, well, every site you give them a /48, without any consideration of whether they actually need anything even close to that size. But then if you're doing that, if you're Walmart and you're Walmart's might be probably too big an example, but you're opening branch offices, on some regular basis across the years. So as you assign new /48s, the allocation that you have to request is probably not contiguous with the block of /48 that you already have, and so that sort of becomes, as you said, becomes impactful on the internet BGP address space.
Well, and that gets back to the original point of, is the 48 what we want to advertise? Is it optimal from a design standpoint? Maybe we don't run, maybe it's fine just running with provider assigned address space, but we just use NAT in exactly the same way that we use for v4, for simply preserving and sort of staving off the problem for the default free zone, and just, getting more efficiency there. That's a reasonable trade-off in my book, especially when you got 10 million mid-sized companies that you don't want to necessarily deal with all of that. And you can still give them the same sort of transition capabilities of leveraging that in the same fashion. It's not really about address conservation, as we all are well aware. That's not the structural issue with v6. It's really more about, are there other resources we need to be thinking about structurally within the internet backbone that are more precious to us versus how much of a size allocation trade-off we do. And I think that's the crux of the discussion. I think that's the crux of what's maybe some of the area that's coming in on the ITF side of, like, what's the right trade-off? What's the right balance?
Yeah.
Today, we don't have an answer for that.
It's very much a Jeff Houston topic.
Well, Jeff actually just talked about that recently with Russ, actually, on Russ's show. He was talking about this and with Russ White. And I do, Jeff's got some really good points in terms of, like, how that plays out and how we need to be thinking about that. I think for enterprises, the very largest fortunes, they're going to have the flexibility of using their own PI space in the way that they want to. And more and more of them, to be honest, are looking like service providers in their own right. Yeah. Many of them operationally. And Jeff, you know this, you've worked with many of them. So you can sort of see architecturally that they adopt many of the same principles that the largest service providers adopt anyway. I think that the problem space is the next level down below them, down to that mid-sized commercial space, where it's like, what do we do? What do we do for those folks? And there's no good answer. There's no good footprint right now. There's no good reference out there that I'm aware of. I'm pretty involved in the v6 community, so I've got a pretty good idea about what's sort of out there and published, but I don't think there's good guidance for organizations that fit in that space. We can solve the space for the upper folks because they look like service providers and a lot of their operational principles are the same. And the home consumer and the mobile side has been solved because you work with all of them, sort of help on that and that transition. So what do we do with the middle, right? And that middle space is that difficult space to try and figure out what operationally works for them. And enterprises aren't willing to spend money just to transition for transition's sake.
Yeah.
Right. That doesn't make any sense. Solve a business problem, solve an application need, or solve a compliance issue. Those are the things that are going to change those organizations to say, like, we need to do this. Well, if you don't give them a good roadmap, if the vendors aren't providing good roadmaps, if they're not providing good sets of, like, practice principles, security principles, everything else that goes on, they're like, we're not going to adopt because there's not a good reason to. I don't know. That's where I think it's at.
Even, talking about NAT v6, that's almost, I used to joke about, when I was a lot more involved in the IPv6 advocacy, that most everybody that did presentations, there was always the obligatory NAT is evil slide. And yet now we're talking about NAT v6.
Well, yeah, I was right there. But I mean, Dan Wing presented back in, 2010 at the Google Implementers event. He presented the whole thing on MPT v6 and some of the corner cases that you can't solve with just using v6, and whether it's PI or PA space, you can't solve some of the corner cases. You needed something as a tool to be able to get there. I remember he got yelled down pretty hard, I think, at that meeting. He had like 5 use cases that he went through. He's like, well, if you can solve these problems with just pure v6 and pure PI space, let me know, but I haven't figured out a way to do it. So I'm throwing it out here for the rest of you folks to take a look at, and you let me know. And he walked off stage and sort of dropped the mic, and everyone's staring around, looking at each other, going like, I don't know how we're going to solve this. We'll hit the big pause button and wait and see if something comes out. So here we are.
As V6 nerds, we sort of, we're at risk of veering into the metaphysical in our objections to NAT, and so it's good to be reminded that these are all tools in the belt, and there are certain operational models that can be solved with this particular tool in a perfect way or a close to ideal way as possible. And we shouldn't shout that down because V6 is cool and you should use V6 instead. So
yeah, I mean that's I think that the approach of V6 purist is kind of naive, that there's still a lot of V4 out there, and and you've got to interoperate, and so question is, and I guess this is getting entirely into speculation, is IPv4 is still out there. How much longer is it still going to be out there? Do you have any insight into when IPv4 itself is going to be obsolete?
Let me go sacrifice my chicken first.
Yep. To read the tea leaves.
Yeah. Maybe the tea leaves is more friendly, more animal friendly. Yeah, honestly, Jeff, that's a hard question to answer, because I don't think, from a momentum basis, I really feel like V6, especially with the U.S. federal government taking their OMB mandate pretty seriously and pushing that very hard, there's a lot more interest in V6 only. I think it's going to be a few years before you're really seeing that tipping point of really the acceleration side of it. The people that are of the largest organizations are really sort of taking on this and trying to address it. And I think we're going to see a little burst of effort around V6 within the IETF and manufacturers and vendors to solve problems.
Yeah.
I think once we get past there, then you're going to start seeing things sort of fall into place, because the tools will then be available for that mid-sized space that we were talking about to really be able to go do the right thing. They'll have reference validated designs, they'll have other things that they can do, and it'll be built and baked into products in a way that is more meaningful for them, because they won't care what the underlying protocol is. So it's going to take a few more years for us to really reach that tipping point of adoption and technology innovation to make the space work. And so for me, I still see that as it's the 5 to 10 year sort of cycle that we're going to sort of see to do that. That's sort of my guess, sort of looking at it. And as someone who's been waving the flag since 2005 around the V6 side, I say those words cautiously, because I was like, I thought everyone was going to be adopting right away back then. So every single V6 person who has looked in those tea leaves has seen something different, and I think we're all guilty of being more optimistic than we really probably should be.
Yeah, I think what Ed's talking about, the government mandate, if you're not aware, is OMB 2107. And it's not a dual stack IPv6 mandate. It's an IPv6 only mandate. There's milestones for these government agencies to have 20% of their devices V6 only, 50%, 80%. And then at the end of that, which is only a handful of years out, you have to have a plan to identify any devices that can't do that and retire or replace them. And what that's going to do, I think, is it's going to add more momentum behind this tipping point that Ed talked about, because vendors now aren't going to be able to lag with respect to IPv6 deployment. And if they want to do business with the government, they're really going to have to step up. And most vendors have, but there's three planes you have to look at if you're going to do IPv6 only, and that's the data plane, the management plane, and the control plane. And I think a lot of vendors are there with respect to the data plane. If you said, do you support V6? They would say, yes, absolutely. Well, then you put it in a V6 only lab and you can't manage it, for example. And, what this mandate is going to do is it's going to, there's always hurdles to any major IT project that you do. And what this is going to do is continually kind of break down some of those barriers to getting to where you want to go. And that's really going to help out there. And so, yeah, I think that mandate will help. When will V4 go away? When will,
Come on, Cody, drop a date and time.
No, I'm not going to do it.
Tom, you're next. What's your crystal ball?
I'm not going to take the bait.
Yeah, I won't either, but I will say that I think, to Cody's point about where the vendors are at, and I think this includes both service providers and vendors, there's additional expense in maintaining dual stacks and products, whether you're managing it on the network or you're managing it in a code stream. And at some point, you're going to pass that cost on to the consumer. Right now, there's buckets of money to be made, by having this sort of halfway V6 support, as Cody mentioned, in the data plane, but not necessarily so great in the management plane. But that maybe there's a tipping point, and this is just speculation, but maybe there's a tipping point where you figure out that if I can get IPv4 out of the stack, either in the product that I'm offering or in the service that I'm offering, then I'm going to save money in terms of development costs, in terms of the OpEx of running it. And then if I have customers that, and where is that tipping point? At what percentage point of, folks that have adopted IPv6, where I can then go back to the customers that are v4 only diehards and say, you have to pay a premium for me to continue to support this. If you want to connect over v4 on the backbone, at the edge, if you want to have me deliver a router or a switch or a middle box or a firewall or whatever that has v4 support, it's going to cost you. You're going to have to pay a premium license for that. So, I don't know. That's always seemed like a tipping point that's out there. How far away we are from that tipping point, and maybe the new federal mandate moves us more in that direction. That always seems to have a lagging effect, but it does have an effect. So maybe we'll see that at some point.
Yeah, and I don't think it's, and as with many things, Jeff, I don't think it's evenly distributed, right? So. You look at India and what Reliance Jio did for India in the span of like 3.5 years of moving them from like 5% V6 adoption. They're like 62% or something now because of just one organization making such significant change. I think many of our peers in the Asia Pacific region are going to beat us to the table in regards to V6 and V6 adoption for the simple fact that they need address space. They need to be able to get on the network, and paying for V4 is just ridiculous. It makes no sense when you can have an unlimited free resource to go utilize in your network builds. And so I think there's just going to be some organizational changes, and and then maybe there's a bit of a calling for the U.S. and a tip of the hat to the U.S. federal government to realize that like they could potentially lose the race on some technology hurdles if they don't adopt in a timely way to keep up with what many of the other folks in the world are going to be doing. Sure. And I just throw that out there. So.
Well, when I was running around, the last time I was at Juniper, I'm back at Juniper now, but the last time I was at Juniper Networks, I was their IPv6 spokesman, and I used to joke that when you wanted to talk to an audience about IPv6, you had to sit on an airplane for 12 hours first because the people that were interested in IPv6, seriously interested, were all in Asia. You had Japan, South Korea, Taiwan that were interested in it because of internet-enabled user devices, and you had China and India that were interested in it simply because IPv4 wouldn't serve these enormous populations that were, more and more going online, and and that's where all the demands were. And I was actually thinking about that earlier. You mentioned they're more sophisticated about it, but probably because they've been thinking about it earlier. But do you see that kind of at least early interest and early seriousness around V6 in the U.S., in Europe, and maybe even Middle East, Africa?
I guess that's a hard one to answer. I think there's innovation that's happening across the board, across all regions of the world. You see Brazil's just picked up tremendously in V6 adoption. But I think this is a need resource of realizing that they need to provide something that can scale for their populations. And so the governments are starting to take a more strategic approach around V6, is realizing that it's a resource they can use to be able to solve some of these structural problems. Our greatest downfall in this is that, we were so early on, internet was invented, part of a US government funded project, everything else. We're carrying all that baggage forward. We have technical debt that we're carrying forward. And V4 is one of those technical debts. We had a plethora of V4 that was made available to us. And we, whether intentional or unintentional, starved the rest of the world of those same equivalent V4 resources. They're sitting at a deficit relative to us. We're still sitting in a relative, not comfort zone, but at least a buffer zone of abundance that was provided for this particular geographic market. And I think it's the US and Europe as the principal market for that. It's just my sort of bias and quick comment. And I think the rest of the world is we don't have that. We're going to go use the abundance that's provided by V6 to be able to solve these structural problems. And if the U.S. doesn't recognize that, if the North American market and the European market doesn't recognize that in the same way, it means you're a laggard. Now, there was innovation that was happening in terms of trying to get V6 lifted off the ground because of the early recognition of the shortcomings of the fact that we were going to run out of address space, and there was a lot of innovation that was happening early on to try and move the ball forward. And I think there was an investment that was done then that sort of peaked out, and then everyone said there's other interesting things to work on, right?
Yeah.
There's other interesting, internet scaled problems. We stem the tide with, with VLSM and with CIDR and with NAT. So we solve them structural problems that gives us breathing room that we can work on interesting things like Web 2.0, commerce, like lots of other things that absolutely 100% needed to happen for the internet to be what it is today. And I'm not trying to take away from any of that, but you solve the problem spaces that meet your needs today, right? And I think the need today is starting to happen with the cloud pressures. Like we're hearing just time and time again, Jeff, folks that are coming to us are like, we only got like 6 months left of our V4 RFC 1918 space left because suddenly the cloud team is consuming everything. Like we thought we were good for the next 10 years. They're going to starve us in the next 6 months. Mm-hmm. Like it's going to be gone. like we need to solve this problem. And they're like, and we can't do this much NAT. It's too brittle. We don't get the routing infrastructure. We don't get the visibility. Like there's a lot of things that are broken there. And I know you guys, automation is the whole thing. Automation is a perfectly wonderful tool to use to actually do V6 deployments. Yeah. It's the best reason to like I can touch everything, I can automate the rollout, I can do the deployment work, but you need to understand the technology and the adoption cycle and the best practices around address allocations. Once you figure that stuff out, we're huge advocates of using automation tooling to actually push all that stuff out because they're like, why would you want to go touch this many routers and then to go just turn V6 on?
Yeah, and Tom, you worked for an IPAM company before Hexabuild. Would you agree that part of deploying IPv6 now is you pretty much have to have IPAM. Trying to do an IPv6 address design on a spreadsheet is ugly. Would you agree with that?
Yeah, the operation. Yeah, absolutely. The operational challenges related to V6. I think initially we're more seen, especially in the IPAM space, we're more seen around the interface identifier and how intimidating that would be to, sort of keep track of addresses in that fashion. And then, moving to the left in terms of bits and nibbles, if you start looking at the overall allocation and how you're going to carve that up, I don't think we've arrived at that sort of watershed moment where you really see the advantage of having consistently sized prefixes that are assigned across the network. And I hope that the evolution of the network isn't so quick that we lose the opportunity to really get that established. And IPAM is definitely a piece of, can definitely play a part in that, can definitely play a role in that. And I'm looking forward to what the IPAM, the DDI vendors and Infoblox in particular come up with to help manage and operate the network at that scale with that kind of carving up of the address space.
Yeah. And I was just reminded that we've gone a little bit past. We don't really honor an end time, but we usually try to shoot for around 45 minutes, and we're a little bit past that. So this is probably a good place to stop. But there are a couple of things that I wanted to plug on your behalf. First is all three of you are at a company called Hexabuild. And I'm sure there are probably other IPv6 consultancies out there. I can't actually name any. And when I'm approached by somebody saying we need help and advice on IPv6 deployment, I point them to you guys. And so I very much, to our audience, just want to say, if you have questions, if you need professional help in an IPv6 planning or deployment project, by all means, talk to Ed, Cody, Tom, and Scott at Hexabuild. The other thing I want to plug, and I haven't mentioned it all, is you guys. Here we are on Between Two Nerds, but you guys also have a webcast. And it's under Packet Pushers, which if any of you are not on Packet Pushers, you really should be. I actually, Packet Pushers website is actually my default. When I open a browser, it's my default website, just because if you want to keep up with what's going on in the industry, that's the place to go. But on Packet Pushers, look for IPv6 Buzz, and you'll find our friends Ed, Cody, Tom, Scott running a webcast there, and we were just talking before the show started. You've got what, 100 and something shows already, all on IPv6.
Yeah, we're coming up on 100 here. We're actually going to have Greg and Ethan on the show for show 100, just as an early primer for everyone. So we got one. I think show 99 is going to come out here shortly, and then show 100 is going to be with Greg and Ethan, just because we can do that, because Greg and Ethan are good guys, and we've been having a lot of fun just doing the show. But like I mentioned to you, Jeff, we were sort of surprised that we could have like 100 topics to talk about around V6, but apparently we do.
That's a very positive thing, I think, in terms of seeing how much interest there is around.
Well, and we've had you and we've had Jeff on for the show. Yep. For both of you guys have been on for the V6 for IPv6 Buzz. We really appreciate you guys coming on the show and sharing your guys' knowledge around V6. It's been pretty awesome.
Absolutely. Thanks for coming on, Jeff. And until our listeners get sick of hearing me say, you didn't get a big enough allocation, then I'm going to continue to say it for however many episodes I can get away with it. I just wanted to do a quick shout out to the person that made that shirt that Cody's wearing, Torbjorn Eklov. I hope I'm saying that right. He's one of our IPv6 colleagues in Sweden. And he's been doing great stuff with V6 there for a long time. The Christmas goat, which if you're not aware of, something to check out. He's like in year 12 of that. But yeah, just a shout out to another IPv6 Fulkin.
Great. Well, I think I'm gonna wrap it up. I would love to do another show at some point with you guys. This has been so much fun. Somewhere along the way, you mentioned Russ White. We've done shows in the past with Russ, and it's the same sort of thing. He's an old friend, and these shows are just so much fun to do, in my opinion. I mean, totally selfish. When it's friends that I know and love on the show, and we can just sit back and chat and let everybody else listen. And
you got to be careful with Russ. He'll go off down in the weeds or all sorts of weird topics.
Oh yeah, and that's that's half the fun of this show, is finding out where what weird topics you can go and find. But anyway, I want Ed, Cody, Tom, I want to thank you for being on the show, and for all of you listening. Please be sure to subscribe to our channel on YouTube, and thank you for listening. And we will see you again in 2 weeks.